imagine I've got my molecule, I don't know, a H bonded to a H. At any one time, electrons could be what, when the examiner would like to say this, unequally distributed. We have an unequal distribution of electrons. So we'll have more electrons on maybe that side of the atom than on this side. So because we've got more electrons on that side is going to have a slightly negative charge. And we show that by that symbol there. And this side will have a slightly positive charge. Now, these slight charges, or these incredibly slight dipoles, will only exist for the briefest moment of a second. However, by one molecule having this unequal distribution of electrons, so just by one molecule having more electrons on one side for a briefest second, if I have another molecule which approaches that first molecule, even if this molecule's electrons were perfectly distributed, spread evenly around it, because this has got a slight positive charge, it's going to attract the negative electrons in this molecule, because opposites attract. So even if this started off with an equal distribution of electrons, this molecule would pull the electrons towards it, inducing a slight dipole in this molecule. So because this is pulling the electrons towards it from this molecule, we're going to end up with a slightly negative side here, leaving this side slightly positive. And then when my next molecule approaches, even if this had a perfect distribution, this molecule is now going to pull the electrons towards it. So just from one original molecule having a slight unequal distribution of electrons, it causes this kind of ripple effect, like a puddle in water, how it ripples out, and it induces the dipoles in the other molecules. Now I've only drawn 3. This can happen for thousands of molecules in a nice line. So just from one unequal distribution, we can get all these attractive forces. And these will keep on going between thousands and thousands of different molecules. Now because these are attractive forces, it's going to pull the molecules together, hence we've got an intermolecular force. And that's van der Waals, small v, small d, capital W, also called induced dipole-dipole forces. So they're the weakest. They're incredibly weak because we've only got this slight charge. Permanent dipole-dipoles are a lot stronger than induced dipole-dipoles. But what I'm going to talk about now is something which eclipses both of those, hydrogen bonding. Now hydrogen bonding is the strongest intermolecular force. You know, it kicks the ass of all the others, it's so strong. Sometimes you'll see this written as H bonding or hydrogen bonding. And this is where we have an O or an N bonded to a H. Now when we have an O or an N bonded to a H, or technically you can have an F bonded to a H as well, because these 3 things are so electronegative, O, N and H, they're so electronegative, they pull all the electrons away from hydrogen so much, this hydrogen is left positively polarized, but incredibly positively polarized. This is a really strong polar charge, and these have got strong negative polar charge. So I'm going to use the example of water. If I have one water molecule and another water molecule, these are going to have my, do a difficult pen, my positive dipoles here on the hydrogens, because these are less electronegative, and my negative dipoles on the oxygen, because these are more electronegative. But oxygen, nitrogen and fluorine have all got lone pairs of electrons. Nitrogen's got 1 lone pair, oxygen's got 2 lone pairs, and fluorine's got 3 lone pairs. So I'm going to draw my lone pairs on here, just by 2 dots. And here's how a lone pair works. Sorry, here's how a hydrogen bond works. The lone pair of electrons, because this is basically 2 negative charges, these lone pairs are attracted to the positively polarised hydrogen. And that's what they wanted to say in an exam. The lone pair of electrons from either my oxygen, my nitrogen or my fluorine is attracted to the positively polarised hydrogen. That's what would be written in the examiner's mark scheme. Lone pair of electrons attracted to the positively polarised hydrogen. And if we ask you to draw a diagram, it would be a 3-mark diagram. You can get your 3 marks as follows. 1 for showing the oxygen attracted to the hydrogen. You'll get your 2nd mark for showing your dipoles, so positive on hydrogen, negative on the oxygen. And you'll get your 3rd mark, and this is what everyone forgets, you'll get your 3rd mark for showing this hydrogen bond coming from your lone pair of electrons. If you don't show it from a lone pair, you'll lose a mark. Okay? So to sum up, hydrogen bonds are the strongest intermolecular force, and they're caused by a lone pair of electrons on either a fluorine, nitrogen or oxygen attracted to a positively polarised hydrogen attached to a fluorine, oxygen or nitrogen. Okay? And that is intermolecular forces.